Good morning. This lesson is about how to use guide. So today we're just going to talk about the first part of guide. So guide stands for givens, unknowns, identify the formula, do math, and evaluate. Today we're only talking about the givens. So givens for a problem. When you do the G step or given step of guide, and then mark your paper with G, and then the givens are all the numbers you're given in the problem. So you're going to record all the numbers you have in a problem. So right now I see this number. So this needs to go into my givens. And this number. And this number. You can tell I'm taking the number and the unit, because in guide you do need the number and the unit. And this number, and I'm going to go ahead and shorten 5.0 seconds to 5.0s, because that's a shorthand for seconds for the unit. And this number. So you might think, if we're just looking at the numbers we're given, and trying to record the numbers we're given, that this is all we need. But you can already tell the problem we're running into, which is that there are multiple of the same units. And so because of that, right, we have a 5.0 meters per second, and we have an 8.0 meters per second. So because of this issue, when you pull out numbers as givens, it's really important that you label them with what actual variable they are. So we will use this strategy all year long. It really, really helps when we get into energy and we have complicated problems that involve 4 steps or more, and we have a lot of different numbers in those problems. In this case, we're just talking about velocity. So we need to think about our velocity equation. So we're looking for V's. We're looking for delta X's. Let me go get a delta. So we're looking for the distance, any kind of horizontal distance, and any kind of horizontal time. And this is how we're going to label our givens. And in fact, we're not even going to, I'll show you how we're going to add on. So we have 10.0 meters. So that is a distance. So I'm going to label that delta X. We also have 80.0 meters. So I'm going to set that also equal to a distance. We have 5.0 meters per second. So that is a time, and that should not be capitalized V, that should be a lowercase v. So 5.0 meters per second is a velocity. Sorry, I think I just said that's a time. 5.0 meters per second is a velocity. So I'm going to label that as a velocity. 5.0 seconds, this one is a time. So I'm going to set it equal to a delta t. And then 8.0 meters per second, again, is a velocity. So you can tell I have multiple delta x's. I have a couple of v's and a delta t.